Greetings, Brookings Bio students. This is Mrs. Rydell, and this is our last little bit of evidence for Darwin's theory that living things change over time. And the last thing on our list, when we made our list way back at the beginning of this slideshow, was that we can see natural selection happen. One of the things that people who don't believe in evolution say is, well, you know, if it happened millions of years ago, no one was there to see it. How do we know that it happened? And the answer to that is that it didn't just happen millions of years ago. It's still happening today. It happens all the time. And we can see those changes in populations. A good example of this is a population of moths called peppered moths. And they're called peppered moths because it looks like someone took a shaker of pepper and sprinkled it on the moth. So they have kind of speckles, like dark speckles, light speckles. And remember, in a population, everybody's different, individual variation. So some of the moths in the population have more black speckles than white speckles. Some have more white speckles than black. Some kind of have an even distribution, equal blacks and whites speckles. And so the moths are a little bit different. And so if you look at populations of peppered moths, where this study was done was in England. And back in England, before the Industrial Revolution, most of the moths that were part of the population, if you looked at a population, remember each one is a little bit different, but the majority of moths in the population were the lighter colored moths. They had more light speckles than dark speckles. And remember, we talked about the Industrial Revolution back in our ecology chapter, and we talked about changes that led to things like pollution, moving to the cities and building more factories, burning more fossil fuels, put a lot of pollution out into the atmosphere, on the buildings, parts of ecosystems. And that was true not only in the United States, but also in other countries where we had a huge increase in building and burning fossil fuels, building factories, and pollution. And so by the middle of the 19th century, if you looked at the moths that were in the population that lived near cities in England, the majority of moths there, we started to see more and more of those darker moths, the ones that had more darker speckles than light. Why would that be? If you're living in a place where there's a lot of pollution and soot covering things, light moths on a dark background stand out. And if you stand out, you're more likely to get eaten. And if you blend in, dark moths on a dark background, on the soot-covered buildings and on the sooty places, less likely to be seen, less likely to be eaten. And the population actually changed. By the late 1800s, 98% of the moths were the darker kind. They increased in the population, and the lighter, and then just like in the United States, we started looking at environmental issues. We started thinking about our planet. What are we doing? Looking at cleaning up, and we passed laws like the Clean Air and Clean Water Act that reduced the pollution, stopped the factories from putting so much out into the ecosystem, and the soot and the smokestacks and the pollution was reduced. And if you looked at what happened to the moths in the population, the lighter ones started to come back again. Less soot, less background pollution. Now those darker moths don't have such an advantage, and the lighter moths started to increase in numbers. We saw a change in the population, the frequencies of those genes, those colors in the population, because of changes in the environment. When we had a dark background, lots of pollution, the darker ones were more common. When the pollution was cleaned up and disappeared, the lighter ones started to come back again. And we saw that happen. This didn't take millions of years to happen. It happened in the lifetime of humans. We can do experiments to show that evolution can happen. This was an experiment done by a couple of scientists, Resnick and Lur, and what they did was look at populations of guppy fish in different lakes. And the guppies that lived in this lake had a different predator than the guppies that lived in this lake. The predator that lived in this lake preyed mainly on the small-sized fish. They ate the babies, they ate the little fish, and not so much on the bigger fish. If you made it to being a grown-up, made it to adult size, those predators didn't bother you. And so what happened was, over time, the guppies that lived in that lake changed, they evolved to survive with that predator. They were larger at maturity, they grew quickly, they got big fast, they reproduced early, because once you got big, then you were safe. You didn't have to worry about the predators. So the ones that were small or slow to mature or slow to get big, those are the ones that got eaten. And over time, the population grew to be larger at maturity. When they got to be full grown, they were a bigger size compared to the guppies that lived in this other lake. These guppies lived with a different predator. They lived with a predator that ate mainly the larger fish, the adult fish. And they didn't really prey on those little tiny ones. And if you looked at the guppy population that lived in this lake, it had actually changed over time to best fit living with the predator that preyed on big fish. So we were selecting in this lake, nature was selecting for fish to survive that were the smaller ones, the smallest size fish. Those were not eaten by this predator. And so over time, if you looked at the population, it wasn't just that they were babies still. It's that when they reached their adult size, their full size, fully grown, they were still very small. Small at sexual maturity compared to these guppies that lived in this lake. They had changed over time to survive and best fit that lake that had that predator that preyed on large fish. So scientists decided to do a little experiment. They took some guppies from this lake and they moved them into a new lake. This was a lake that was a man-made lake, and it didn't have any fish in it, no guppies in there prior to moving. So we take guppies, these smaller guppies, and put them into this lake. And now we changed the predator. We took the predators from this lake and added it to the guppies in the small guppies here. And then watch to see what would happen over time. What happens to this population if you have small guppies introduced into a lake with a predator that eats small fish? And what happened was the smallest ones got eaten, because that was the predator that was preying on those small fish. And in the population, those, even though they were smaller, the ones that were the biggest size survived. Those were the ones that made it and lived and passed their larger genes on. And over time, what happened to the population was it got larger and larger and larger. Over time, we were selecting for, nature was selecting for, the fish that had the biggest size to survive, because those are the ones that weren't being eaten by this predator. And it actually changed the population. And this didn't happen in millions of years. This happened within like 11 to 20 years. The average size and age at maturity of the guppies in that transplanted lake increased compared to guppies in control populations. They matured faster, they got to be a larger size quicker, and those were the ones that were selected for. And they showed that guppies in that lake changed, the population changed in a fairly short time, evolutionary time, to become different. We could see evolution happening. We see evolution happening all the time with new diseases that pop up. There are mutations that happen in viruses and in bacteria that cause a change and result in a new disease. Right now we are hearing in the news about bird flu. Every flu season there's a new strain of virus that comes causing diseases. Each year you get a new flu shot because it's different than the flu virus from last year. And right now, Minnesota, South Dakota, we're dealing with bird flu in our flocks. We're killing those turkeys and the chickens on farms because they are infected with that flu virus. HIV. There was a time when we didn't have the HIV, the AIDS virus. It's a mutation of a monkey virus that changed to become different and allowed it to infect humans and caused a new disease. We see it in the antibiotic resistance that we're seeing in lots of different bacteria now. We have MRSA, antibiotic-resistant tuberculosis. We're getting more and more organisms that are resistant to the antibiotics, the medicines that we use to cure them, and it's because of evolution. Mutations happen, those populations are changing to become different. We see it in the chemicals that we use on our farms, to the insecticides and pesticides that we apply to our crops to kill the bugs that eat them. Those chemicals, those pesticides, when you put them on a field, they don't kill every single bug. They kill most of the bugs. But there are a few, remember, in a population, everybody's a little bit different. There's some of those bugs that have a mutation that allow them to resist the pesticide. They survive. Even the chemical kills all of the other ones. There's a few that survive and reproduce and pass that resistance gene onto their offspring. And what we're doing by using these chemicals is we're selecting for, we're breeding those organisms that have the resistance gene. We're making populations of bugs that can't be killed by the chemicals that we used to use on our farms. And the same with antibiotic-resistant diseases and bacteria like tuberculosis, sexually transmitted diseases like gonorrhea, syphilis. We have strains of those bacteria now that can't be killed by the drugs that have worked in the past because they are changing, and we're selecting for those individuals in the population that have resistance to our drugs. We're going to watch a short movie about how that works.
Why does evolution matter now?
Evolution matters now because it happens every day in our lives. A perfect example for looking at this is in sicknesses, which are caused by microbes. Microbes are small particles that are able to cause disease in human beings. They include things such as bacteria, viruses, mycobacteria, fungi. And their evolutionary world in which they try to survive is inside the human being.
Viruses, bacteria, and other microbes may be all but invisible to us, but that doesn't mean we don't play a huge role in their evolution. The way we use antibiotics, for instance, has a lot to do with which ones survive, the helpful ones or the harmful ones. Tuberculosis, the leading infectious killer of adults in the world today, is caused by bacteria. And it has become one of the most lethal, especially in Russia, where evolution on a cellular level has resulted in some tuberculosis bacteria that are resistant to drugs, threatening the survival of hundreds of thousands. This is ground zero of a global tuberculosis epidemic. Russia's crowded prisons provide a perfect breeding ground for the transmission of tuberculosis.
Tuberculosis is spread through the air and is therefore a very threatening disease in that someone could cough and a few hours later someone walking into that room could inhale the air and become sick with tuberculosis.
People who do become sick with tuberculosis develop a cough and fever and begin losing a lot of weight.
If you look at the x-ray of the healthy lung, what you see is a lot of dark areas within the lung. That's because the lung is primarily composed of air, and that indicates that there's a healthy lung. When you look at the tuberculosis lung, you can see that there are many white areas. What's in there is a lot of phlegm